Welcome to Electronics Techie. So in this video we discuss about full adders using half adder. So till now we design half adder and full adder separately, but how to design full adder using half adders, in this video we discuss about that. So in market, if you want full adder, but in market there are only half adders, then by using these half adders we have to design full adder. So how you design means just look into this video. So you know that full adder, but for full adder there are the three inputs. In previous videos I already say how to design the full adder. If you don't watch it, then go through that. If you don't watch half adder also, go to that, then it is easy to understand this code. So for full adder there are the three inputs, A, B and C or C, and you can mention anything. So first two inputs, what are the full adder? Full adder has A, B and the C. Here we represented C, so three inputs are there. So first two inputs are given to half adder. So here you can observe A will be and B will given to half adder. Then the output will be the, for half adder the sum and carry will generate. So this is the sum, this is the carry we observe. So again another half adder, the output of the carry of it is the carry. A into B is our carry and A XOR B is our XOR gate. So the sum of the first half adder will given to the input of the second half adder. Second half adder also there are the two inputs, input 1 and input 2. So for first input what you have to go to give, so output sum, what is the output sum drawn by the half adder will given to the input to the half adder 2. So again remaining third input will given to the half adder. So again we get sum and the carry here. So now what you do, sum is directly is our full adder sum. Full adder, what is the full adder sum? It is our direct sum we get from second half adder, but the two carries of the two half adders will be OR operated, and then C out will come. So carry 1 OR operated with carry 2. So two operators will perform OR operation, then it is our full adder carry. So finally we get three for full adder. There are the three inputs and the two outputs here, but middle of the operation what we have to done is half adder operation. We use two half adder to design a one full adder. So it is our internal circuit diagram. It seems like this. So first here in the previous we can take it as A, B and C, and there are the three inputs. So first two inputs are given to the half adder, but inside where you give, so A, B are given to the XOR gate as well as the AND gate. By giving A and B values for XOR gate and the AND gate. By XOR gate we get sum, and AND gate we get carry. So now what you have to do, this sum will give to second half adder. So second half adder means then you simply give like that. So one of the input is sum, and here we can observe another input is Cin. So see, another Cin will here, this is the line, so you can observe this line. So it is our Cin. We give this to the XOR gate as well as the AND gate. So again sum and Cin are given to XOR as well as sum and Cin are given to AND gate. We generate sum and the carry again. So for final full adder sum, it is our final full adder sum. But carry, how you get carry? So first generated carry means first half adder output carry, and the second half adder output carry will going to done OR operation. Then we get the full adder carry. So like that, by giving three inputs we get sum and the carry. It is our schematic diagram, it is our block diagram. So till now if you have any doubts you can comment it. So just look into the code. So why I represent this block diagram here means, for writing code it is very easy to understand. So first what you have to do is start with module and end with end module. Here we can see there are the two codes. Why you use two codes? Here we have to use half adder using full adder using half adder. So we have to instance this half adder, means we have to use the half adder design code. So this half adder in Verilog we have to write a code. So by using half adder code we have to design the full adder code. According to full adder code, if you discuss in Verilog side, so first of all what you have to do, first you have to write half adder code, then you have to use these half adder codes to design the full adder. So first you simply write the half adder code. We already discussed in the previous video. So module half adder, it is our module name. So what are the inputs here? A and B are the inputs. So simply write input A, B, and the outputs are sum and, so this is the carry and this is the sum and carry are our outputs. So for sum formula we already discussed that A XOR B. Here you can observe. So in Verilog the XOR gate symbol is like cap. So for AND operation it is like ampersand. For OR operation it is like single line. So why you use assign means in data flow modeling we have to assign the RHS value to LHS value. That's why I use assign keyword. By using these assign keyword, the X or B will assign it to sum and the AND operator will assign it to carry. Like that we design the half adder. Now what you have to do by using these half adder. So by using your half adder code you have to design the full adder. For how you design, let's see. So first again you have to start with module and end with end module. So it is our another code. So we have to instance this half adder code in this full adder. So just see. So we have to write again module name. So module followed by module name, and again you give to input ports or output ports. So for full adder how many inputs? A, B, C are the 3 inputs and the outputs are sum and carry. Just we have to remember the full adder only. So for full adder, if it is a full adder, for full adder there are the 3 inputs A, B, C and the outputs are sum and the carry. So we have to just remember these things. So for full adder A, B, C and the sum and carry. So that's why you simply write A, B, C input port. So output means output port. So sum comma carry. So now what you have to do means I explain this line while explaining this codes. So just see. So half adder. So first why I write this design code here? By writing this design code in this code means if this module is instanced here. So how you write what you want to instance? So you have to write that module name here and followed by instance name here. So you can write any instance name. For my convenient I write my name. If you want you write your name and you can use anything. It may be related to electronics, it may be professionality, but for your understanding I simply mention my name. It means so you can write any name like specification like that. So no specific thing, you have to write only particular that one, this one. So when you are doing something in high levels, use professionality towards DUT, UUT like that. Otherwise you simply use any name for while you are practicing. So it is our port connection. So how you will connect your ports? So now see how you connect your ports. So for A, B and the sum. So now you have to observe. So what you have to do means, so for half adder, it is our half adder. So A, B are your inputs and the sum and carry are our outputs. So it is our inputs and outputs for a half adder. So now what you have to do, you have to connect the full adder to half adder. So how you connect? So full adder A is given to, so you have to see this diagram. It may be okay, you can see this only. So these A means full adder, these are the full adder inputs. So these A will connected to the half adder A. So this is A and B we think. So just I want to erase it. Wait a minute. So now see. So if these are the full adder inputs. So just imagine like that. Full adder in full adder. And these are the full adder outputs. So just remember like that, these are the full adder inputs, these are the full adder outputs. So for half adder A, B are the inputs. So for again second half adder, what you have to write here, we can use simply a connection. A connection is nothing but by connecting two ports we represent it as wire. So we can take any variable, we have to write means it simply carry these output to this input port. So for carrying from one point to another point without any storing of values, we use wire data type. You can use any name. So that's why here I represented with wire of W1, W2, W3 like that. So 1 minute. So now you can see. So first what you have to do for half adder 1. So it is our half adder 1. So AB are connected to the AB. So we simply write the A is connected to A of full adder and B is connected to B of full half adder. Means full adder A is connected to half adder A. So full adder A is connected to half adder A, and the first we have to write half adder variable and inside what you want to connect. So for A is connected to full adder A. So B is connected to full adder B and the sum. So full half adder sum. So half adder sum is our half adder sum. So what you have to do? So you have to simply represent it with W1. So we have to simply write a wire W1 here. So for again what you have to do? So it is our cursor. So ignore this. So you simply carry. So carry is connected to which part? So carry is just traveling from means connect by this half adder to this OR gate. So it is also just wire. So that's why we mention some variable. So it will be represented in the wire data type. So for representing two wires, so W1 and W2, you simply write two variables in this wire data type. So next, second half adder. So just look into the second half adder. What you have to do, just write module name. So next, instance name, you can write anything, but don't write whatever write in first, and don't, it may be different, means it is like illegal, means it may be duplicate, so don't use that same names here. So use different names for these two lines. So for then again half adder A. So again there is a second half adder, I simply drawn here, so for without confusion. So second half adder and the sum and carry. So now half adder A is connected to which port? So sum. So for in sum, what you have to represent here? So the sum is represented with W1. So simply write A of W1. So next, what you have to done? So B is connected to, simply the second port is connected to C. So that's why here we can simply write, in this code we represented with C. So that's why you simply write B of C, means B is connected to C and A is connected to W1. W1 is nothing but our first half adder sum output. So that's why I write like that. So sum is directly our full adder sum. So that's why you can simply write sum of sum. So for carry, so again this carry is going to transmit to OR gate. So it is not our final output. For carrying this purpose, so we can use another wire, that is W3. So now what you have to do, this wire name is W2, this wire name is W3. So we have to OR operate these two values and get the full adder output. So now what you have to do means, we know that gate level modeling. So how it represent? So you have to write primitive or end or what you want the operation. You can simply write that primitive and followed by instance name. So first in gate level modeling, I say that output is followed by inputs. So first, what is our output here? Final full adder output. So final full adder output, what you have to represent it in the ports? So carry. So that's why I simply write carry comma. So what are the inputs of the OR gate? W2 and W3. Simply write W2 comma W3 and the semicolon end module. So like that we can stop module with end module. So it is our design code. If you have any clumsiness, so just try to repeat another time. So till also you don't understand, then say, while doing code I try to explain, means while typing and while executing I type every step in the EDA playground, then I try to explain more detail. So until then we just go to Testbench. So in full adder, what I say, the Testbench is looks like same here also, same Testbench, but module names and instance name may be different. So you have to watch the full adder Testbench code. So it is similar to this. So you just simply change the module name. So what you have to write the module names in design code, you simply write the module names here. So go through that video, then you can understand Testbench code. If I also explain in this video, the video length may be very large. So already I discussed. So I give this full adder link in YouTube description box. You can click on that, then you get full adder code and there is a Testbench code. So just go to that and then refer to that. So if you want particularly this code explanation, then also you can comment it. So it is our final output waveform. You already know the full adder truth table like that. For the I represented here. So the values are given here. A is equal to 1, B is equal to 0 and C is equal to 1. So what is our sum formula? A XOR B XOR C. So carry formula is nothing but AB plus BC plus CA. We can simply substitute these values in these two. I already discussed these all. So then we get carry is equal, sum is equal to 0 and carry is equal to 1. So if you have any doubts, you can comment it. Until then, thank you for watching, and then bye.